You know, every single day we're hit with stats, polls, and studies telling us what everyone thinks or what they're going to buy. But have you ever stopped to wonder how they know all that? Well, it all boils down to this really powerful idea called sampling. And today, we are going to break it down nice and simple.
I mean, it seems totally impossible, right? How can anyone possibly figure out what an entire country is thinking without talking to every single citizen? The time, the money, it's just not going to happen. So what's the secret? How do researchers pull off this amazing trick? Well, it all starts with an idea you already use every day.
And that secret is soup. Seriously, think about it. When you make a big pot of soup, you don't drink the entire thing to see if it needs more salt, do you? Of course not. You just take one good spoonful. That one spoonful is your sample, and if you've stirred the pot well, it tells you everything you need to know about the entire population of soup.
And that's really all sampling is, in a nutshell. It's the science of picking that perfect spoonful. The whole goal is to choose a small group that's a perfect miniature version of the larger group, so we can be confident that what's true for the small group is also true for everyone.
Okay, so here's our game plan for this explainer. We're going to talk about what it means to get a taste of the whole, explore the two main ways to do it, look at some specific methods for both, and then tackle that huge question: how many is enough? And finally, we'll see why this all matters so much. So, getting that perfect taste or sample isn't just about dipping a spoon in at random. There's actually a really structured, careful process that researchers follow to make sure that spoonful is telling them the truth.
And here it is, that six-step journey. It all starts with being super clear about who you're actually studying. That's defining the population. From there, you figure out how to access them, pick your technique, decide on your sample size, actually collect the data, and then finally, you step back and assess how it all went. Every single step is there for a reason. Now, when we get to that third step, choosing a technique, researchers basically come to a huge fork in the road. And honestly, pretty much all sampling methods branch off from these two main paths. The one you choose changes everything about your results. And here's a look at that fork in the road. On one side, you have probability sampling. This is all about random chance. On the other side, you've got non-probability sampling, which is based more on convenience or a researcher's specific judgment. And the difference between them, it is absolutely crucial. So here's the deal. Probability sampling is like a fair lottery. Every single person in the group has a known and fair shot at being picked. That randomness is the secret sauce for getting a sample that truly represents the whole group. Non-probability sampling? That's kind of like asking your friends for their opinions. It's easy, for sure, but the group you end up with might not reflect what everybody else really thinks. All right, let's walk down that first path, sampling by chance. You know, these are the gold standard methods. When the goal is to say something about an entire population with real confidence, this is where you turn.
The most basic one is called simple random sampling, and it's exactly what it sounds like, drawing names out of a hat. Every single person has a totally equal chance of getting picked. Its biggest strength is that it's the purest way to avoid bias. The catch? You need a list of every single person in the group, and for big populations, that's often just not possible.
Okay, but what if you need to make sure you hear from specific groups? Well, that's where stratified sampling is brilliant. First, you slice your population into important subgroups. We call them strata, like, say, grade levels in a school. Then, you do a simple, random sample within each of those groups. This way, you guarantee you have voices from the freshmen, sophomores, juniors, and seniors. Now, cluster sampling is a total lifesaver for really big, spread-out studies. Instead of trying to pick out individuals, you first divide the population into natural groups, or clusters, like all the company offices in different cities. Then, you randomly select a few of those entire offices and survey everyone inside. It's way cheaper and more practical than trying to sample one person from every single office across the country. Okay, let's back up to that fork in the road and check out the other path, sampling by choice. Researchers use these methods when random selection just isn't possible, or when the goal is more about getting deep insights from a specific group rather than generalizing to everyone. So the most common one here is convenience sampling. And yeah, it is exactly what it sounds like. You just survey whoever is convenient. You see that reporter on the street corner interviewing people walking by? That's it right there. It's super fast, it's super cheap, but, and this is a huge but, it's incredibly likely to be biased. The people on that one street corner probably don't represent the entire city.
Snowball sampling is such a cool technique. It's used when you're trying to find people who are hard to reach. You start with one person who fits your criteria, and then you ask them, hey, who else do you know like you? It's perfect for studying really specific communities, like collectors of rare stamps or members of an exclusive club. Your sample just grows and grows, like a snowball rolling downhill.
All right, so we've talked about the how, but there's another question that everybody has. How many people do you actually need to talk to? Is it a dozen, a few hundred, thousands?
Let's go back to our pot of soup for a second. If the pot is gigantic, do you suddenly need a giant ladle to test it, or is a normal spoonful still good enough? Well, the answer is a little more scientific than you might think.
It turns out that the right sample size is actually a balancing act. Researchers have to think about the total number of people in the group, how confident they need to be in their results, and how much of a margin of error they're okay with. And this is where it gets really fascinating, and maybe a little weird. Take a look at this. To survey a group of 10,000 people, you need about 370, okay? But to survey a population of 1 million, you only need 384. The required sample size pretty much flatlines after a certain point. And that's an incredible insight. You don't need a huge sample to understand a huge population.
So we've gone through the different methods, we've even looked at the math, but let's bring this all home. Why does any of this matter? Why is getting the sample right so unbelievably important?
This quote really says it all. Now, external validity and generalizability, those are some fancy academic words, but all they really mean is this. Can we trust that the results from our little sample actually apply to the real world? A good sample is the bridge that connects your small study to the bigger truth.
So what's the big takeaway for you? It's that you now have the tools to see behind the curtain of all those polls and headlines. You get why a tiny, carefully chosen random sample of 400 people is way more powerful than a massive, biased sample of 4,000. You've basically just leveled up your ability to be a smart, critical consumer of information.
So I want to leave you with this one final thought. The next time you see some shocking poll result, I hope you won't just look at the final number. I hope you'll stop and ask that all-important question. How did they choose their sample? How good was their spoonful? Thanks for joining me.